of technology and after-treatment systems with a presentation from Stephen Lee, who's joining us from KUS. He is Deputy General Manager, Marketing and Product Application. He has a background in material forming and control. From 2010 to 2013, Stephen was the project leader for SCR dosing system components and is currently the leader of marketing and application. So he works a lot with customers to work out what customers require from the KUS products. He's going to tell us about effective methods for AdBlue quality management on vehicles and in AdBlue tanks. And this is going to cover experience of SCR AdBlue tank technology, how to integrate that into the supply module and other components, and then OBD developments regarding level and quality. So great to have you back, Stephen, and the floor is yours. Go ahead.
Thank you, Tim. So glad to be here. It is really a good conference that we can share more experience and also can help us to do better products to improve our system or the vehicles. To be here, I think the climate change is a very serious problem for all of us. I think most of you already know, last week in some western cities in US, the people there, they suffer extremely hot temperature. And the temperature even reached the highest record in the history. Some cities like Phoenix, the temperature already close to 50 degrees C. There is 122 degree F. And it is a really serious problem. However, the US government, they didn't do too much help this situation. And they just quit the agreement, which we already make deals in Paris. So for me, I have a suggestion. It's a very simple and easy solution for the government. Is that the government maybe can change their temperature unit from degree F to degree C. That the number looks better. So it's just a joke. So back to my topic. The environment is really important for most of us. So that's why every year we come here to attend Interjet to discuss more about the environment, how we can improve our environment, how we can improve our system or vehicles. And today my topic is about AdBlue quality management on the vehicle and also inside of the AdBlue tanks. So before I start my presentation, I would like to use several minutes to introduce our KUS group. So for KUS group, we started from 1984, and till now we have more than 33 years experience in the market. Our headquarters located in South China, close to Hong Kong. And besides South China, we also have some facilities in Shenzhen, in Hefei, and also we have a second R&D center in Taiwan. And in India, we also have our facility in Chennai City, and this facility will start to manufacturing to supply Indian market later this year. In Europe, we also have our sales, technical, and also logistic support in Eindhoven, Netherlands. In the United States, our company located in Fort Lauderdale, Florida. And this company already in the market for more than 20 years. And typically for KUS group, right now we have more than 3,600 people globally. And we have more than 200 engineers in China and also in Taiwan sites. So for our group, the main point is that we supply all these products to the market for many years, and most of the products manufactured in-house, even all the components, we integration all the process in-house. So more than 95% of the key components we are making in-house. So this is why we have so many people to make these products. For our product side, the first main product is AdBlue level sensors. We are the first one in the market to introduce this AdBlue level sensor to European. Ever start 2003 with Daimler Group. And right now, every year we make more than 2 million AdBlue sensors globally. And this year, probably close to 3 million AdBlue sensors. So we take about 80% of the global market share, both on on-road side and also off-road side. And for the AdBlue tank side, it is also another key component for us. And these products we also manufacture close to 1 million tanks every year, especially in Asian market. For the fuel level sensors, we also make a lot. This is our first sensor we bring to the market. And for this sensor, we already have more than 20,000 different types in the market. And every year, we also make close to 2 million fuel level sensors for heavy-duty truck and also buses. Besides this sensor and tank, we also make a lot of components, like for the supply module housing or other components for the dosing system and also the nozzles. Besides this, we also have some application for the marine and also genset application for the instrument and also the engine sensors. So for the customer side, we cooperate directly or indirectly with most of the OE in the world. For the on-road side, we have a lot of customers in commercial vehicle, light-duty vehicle, and also passenger car business. And in off-road side, we also have a lot of famous customers. And for the customer side, sometimes we also cooperate with engine company or system company to provide more solution components for them, and then they make a package for the OE side. So back to the topic. For the product side, especially for the on-road and off-road side, there is still a lot of challenge on the application side. The environment is really a challenge for the product. You can meet a lot of temperature change, low temperature, or dust, or water, or very high vibration. So how to design your product properly to meet all this kind of application? It is really important. So first of all, for our tank system, how to keep the cleanliness inside of the tank is also a very important work. So for our tank design and also sensor design, we have different filters to make sure there is not so many particles inside of the urea after a long time application. Especially for the off-road application, the environment even worse, a lot of particles everywhere. So for our tank side, we have filters on the feeding port, and also we have filters on the sensor bottom. For the filter side, we also have different filter for options. We have 2D filter, and also we have 3D filters. The mesh size from 35 micron to 100 micron. We offer different solutions for different customers. So besides the cleanliness side, there is also another challenge on the environment. You know, for all the machines and vehicles, in the winter time, we will face a lot of low temperature problem. The urea is very easy to frozen under minus 11 degrees C. And this frozen will bring problem. The liquid will become to ice, and this ice will expansion at least 7%. And for our tank side, we have to design to have enough space for this expansion. So for the tank design side, we use our filler neck and also air ventilator to make a whole system. And whatever you use machine to refill or you use manual way to refill, still we can keep at least 10%, sometimes 15% space for the expansion volume. And in the winter test, we do see a lot of failures in the market. Because of their tank, they didn't have very good design to avoid such problem. And during frozen stage, there will be very high pressure. And the tank is very easy to broken during such high temperature. Sometimes even the sensor will be break. Like we do see some failures on the winter test. The sensor is also leaked in the coolant side. A lot of coolant liquid go into the AdBlue tank. So how to design the tank is also very important. For some of the application, for the minivans or the light-duty vehicles or some of the buses, we also need to have the feeding tube. And to use this feeding tube is more difficult to control the refilling leakage. So how to design the air ventilation and also the feeding port angle and also some other special design, that is really very important. In United States and Europe, typically for the on-road side, you use machine to refill the tank. There is not so big problem. But in some emerging markets, like China, India, Russia, or even in Brazil, sometimes they use the manual way to fill the tank. And this is very easy to make the tank fill too much. And this will create a lot of problem during the winter time. And for this feeding tube design, it is also very important, like if there is no structure on the feeding tube side, under certain angle, the liquid will go back to the feeding tube. And even in low temperature, the ice will also frozen inside of the feeding tube. And this also creates a lot of problem because for this feeding tube, we don't have any heating element on this section. So we have to also have a special design like the small gate to make sure there is no leakage go back to the feeding tube. Besides the frozen problem, another problem is about the heating. As we know, the tank and the supply module, we have coolant fitting or electric fitting, but for this heating side, sometimes the challenge is on the connection area, especially between the sensor to the AdBlue line or AdBlue line to the supply module. Still, there have some gap between this heating element. And during the winter test, the cold wind is very easy to take away the heat from the AdBlue line. So in the market, there are several solutions. Some of the AdBlue line companies, they will provide an additional cover to protect the heating side. This will also help to sew in the heating in a very short time. And also, some OE sites, they also have additional rubber cover or plastic cover on the sensor head to keep the heat on the sensor top. And for our solution, we also have very cost reduction solution. That is, we can add some rubber part on the fitting side. And this rubber part also will hold a lot of heat during the sewing process. So for some of the vehicles, they choose the supply module integration inside of the tank. And this supply module, they have electrical heat on the body. But for some of the tank, if the tank size is too big or the volume is too large, like more than 20 liters, sometimes the supply module is not enough to store in the AdBlue for continuous AdBlue dosing. So for this kind of application, we can also have additional coolant heating tubes or electrical heating element. We place this around the supply module to improve this kind of heating performance. And this also works very well in some of the customer sites. Besides the heating side, as I just mentioned, there is still a challenge for the sewing between the AdBlue line to the supply module to the AdBlue sensors. So how we can also have another solutions, there is we also have more integration solutions. For the standard one, we have independent supply module AdBlue line and also AdBlue tank. But for some of the application we work with, like the system company like Bosch or Cummins or Tenneco or others, we create a lot of new integration solutions. We can integrate the supply module and the AdBlue sensor as a whole unit. And there is no more AdBlue line between the sensor to the supply module. And this solution already used a lot in emerging market. And it is a very good solution till now in the market. There is less connection, less leakage risk, and also less material. Maintenance is also very easy. And most important is also cost reduction. And this is really popular right now in the market. And besides that one, we also work with a lot of other system companies. We have other integration solutions with the sensor with the supply module on the tank top side or inside of the tank, but on the top side. Or sometimes we can also integrate the AdBlue pump on the sensor bottom. And on the top of our sensor, we can have a housing to place all the electronic control unit. Like the DCU, we can also integration on the sensor top. And these solutions we already have in the market. And this is also very popular solutions for China, India, and also Brazil market. And besides this, we also have some other solutions with Bosch. Use their standard DNOS 2.2 and 6.5 supply module. We can also achieve the same target. There is no more AdBlue line between the Bosch supply module to the sensor. And we can also pick up the AdBlues from the tank directly to the supply module. There is no heating lines between the tank and the supply module. And this also will start in the market for some of the projects. So besides these supply module integration solutions, we also have a lot of integration on our sensor side. For our AdBlue level sensors, we already have a lot of function on the sensor side. We have level detecting, temperature detecting, heating, and AdBlue pickup and return, and also filtering. And for some of the application, we can also integrate the coolant valve on the sensor top. And for the standard one, you also need a standard coolant valve with a mounting bracket and also a coolant tube connection. But for our new design, we just mount the core element from the coolant valve to our sensor head. There is no more mounting bracket and also no more connection. This is also very good solution. Right now, we already sell this sensor a lot in United States market and also China, India market. And this also material, we don't need so much material and also less connection, less leakage risk. For the coolant valve side, this coolant valve is also very easy to do the service work. This valve can disassembly independently. And very important is also cost-optimized solutions. And for some of the light-duty vehicles, because there is not so many mounting space on their chest. So how to integration more function as a whole unit is much benefit for this OE side. So this is why we have done a lot of integration, both for the supply module, the tank, and also the sensor side. And back to the quality sensor side, I think most of you already know the quality sensor for many years. It is driven by the regulation. In Europe and United States, for the on-road side, the regulation requires the urea quality monitoring. Either you can use quality sensor to check directly, or you can use a calculator way to calculate the urea concentration. But if you use quality sensor, it is more benefit for the driver or for the OE, because the sensor can have very quick sensing. If the driver and the user, they refill the wrong liquid to the tank, and after several seconds, this system will give an alarm and the SCR system will not start. So this sensor also can help to protect the system. We do see some failure in the market. Sometimes the people, they fill the diesel oil into the tank. In the summertime, not only the SCR system will fully damage, sometimes the truck will also get fire, and it's also very dangerous for the end user. So use this quality sensor can help a lot. Besides that, in the market, there are a lot of suppliers for the AdBlue side. In Europe, there are maybe only 3 or 4 main suppliers in the market. But in emerging market, in China, you cannot imagine there are more than 1,000 suppliers for the AdBlue liquid. So it is really a challenge how you can control the urea quality in the market. We saw a lot of failures because of the urea concentration is not good enough. Sometimes they only have like 20% or 25% of the urea, and this will create a lot of emission problem. So use quality sensor. If the urea concentration is too low, we can also detect by the quality sensor. And for the driver side, cost driving is always exists. So how we avoid the system to be cheated, this is also very important. So use the quality sensor. It is also helpful for the OE side to avoid such kind of cheat to the system. For the quality sensor side, right now we have several principles. Typically, we have optical quality sensor, ultrasonic quality sensor, and also heat transfer quality sensor. We cooperate with different partners to have these solutions. And the first one is optical way, and I think later today, this afternoon, we will also have our partner TT to introduce this optical sensor. We work with TT for this optical sensor. We buy the key element, and we do the integration and also the software treatment for this kind of urea concentration sensor. For this sensor, it also work pretty good in the market. The accuracy can achieve 2%. And for the ultrasonic sensor side, this is also a very good sensor. The accuracy is even better, can achieve plus or minus 1% in some condition. We also have another thermal conductivity sensor. This is also a sensor which already in the market for more than 10 years. And this sensor, for the new sensor side, also can achieve 1%. For the whole lifetime, we guarantee 2%. So quality sensor is a very high accuracy sensor. So during the application, there is a lot of challenge on the environment side. The first important is bubbles. The bubbles is always everywhere inside of the tank, because there is a lot of vibration, sloshing, or the temperature change, or the pressure change during the vehicle operation. So there are a lot of bubbles, the big bubble, tiny bubbles everywhere. So how to make sure the bubble will not go inside to the measuring area, or we can let the bubbles escape from the measuring area as quick as possible. Then we can get better results for the sensor side. So for the sensor side, we have a lot of design for the out frame to protect the bubble. It's not easy to go inside. And also we use our software to solve some of the bubble issues. Besides that, another problem is the dust. There is also a lot of dust inside of the tank after a long time using. So how to make sure the sensor will not affected by the dust is also important. We have done a lot of tests to make sure the quality sensors still are sensing the urea concentration properly, even in some dust condition. Because we have our filter on our AdBlue level sensor. So we have to make sure under certain dust, the AdBlue quality sensor still can sense it properly. Another challenge is like the temperature change, vibration, or the high and low temperature cycling. This is also give a lot of impact to the urea quality sensor. So we have done already a lot of tests for different principal sensors. Besides the urea quality sensing, the level sensing is also very important. For our company, we also have several technology for the urea level sensing. The first of all is the reed switch level sensing. We already have this kind of technology in the market for more than 30 years. And KUS is also the first one to bring the reed switch technology to the level sensing area. And right now for the commercial vehicle side, heavy duty, middle duty, or the bus, or most of the machine sides, we still can use the reed switch to achieve the level sensing for the urea. But for some of the special application, like the passenger car or the light-duty vehicle, they have very short tank. So for that kind of application, for Euro 6 stage, the resolution requires higher resolution. So we also have technology to achieve this high resolution. We have MR technology, and this technology, the resolution can be 1 millimeter. And also we have our ultrasonic level sensing. This is also very high resolution solutions for this kind of passenger car or light-duty vehicle application. So, come to the end, what KUS can offer to the market. We have more than 30 years experience in the market, and we work with a lot of OE system companies to make a lot of integration solutions. We are not only a sensor supplier, we are more like a solution supplier. We have tank solution, sensor solution, supply module solution, and also coolant valve bracket. We can integrate this more function as a whole unit, and this is also very helpful for the OE or the system company to design their vehicle. So in the company side, we also manufacture most of the components in-house. So we are one-stop company. You can have design. From the design side to the final assembly, we can have all the process in-house. So our vision is that we clean the air for everyone. So thank you for your time. Thank you.
Thank you. Thank you, Stephen. I see the range of products you offer to do with urea sensing is impressive. We have time for a couple of questions, so please raise your hand if you have a question. I'll start with a question. Stephen, you said that you have sales of about 2 million units of urea sensors, I guess level sensors,
yes,
globally.
Yeah.
Can you tell us how how much interest you have for the quality sensor, and how many of you do you sell a year, and where do you see the interest? Is it in Europe or China, US? Which applications? Is it non-road or commercial vehicles? Where's the interest for the quality sensor?
So for the quality sensor side, because the quality sensor is still not so high percentage, even in United States and in Europe, only certain vehicles like Daimler or Volvo, they still don't use quality sensor for the trucks. For the off-road side, because for the United States market, the off-road side, the monitoring requirement, the quality sensor to use the quality sensor. So for the off-road side, there is more quality sensor. For on-road side, some OE, MAN, Scania, they will choose quality sensor, but the top two, the Daimler or Volvo group, they don't use quality sensor. So for our quality sensor, we already have some of the application for these big customers. And right now, like 2 million AdBlue sensors in China takes about 1 million already last year. But in China, it's still China 4 stage, which is Euro 4 stage. And this year, we'll come to China 5 stage. And the volume will increase much more because of China 5. There is a lot of light-duty vehicles. They will start to use SAR system. So for the other 1 million, Europe, United States, or South American market, as I just mentioned, some OE, they do use quality sensor, but the top two, they don't use. So for this side, it's also, we'll see a lot of increasing, but not 100%.
And which, when you do have interest in the quality sensor, which of the censoring techniques is normally chosen? You know, you said you have a range of, you had the thermal characteristics and the optical. Which is the normally used sensor?
It is a really good question. So for the quality sensor side, we have 3 principles. But for KUS side, we don't have any prefer for the technology side because this is more cost-driven. Some customers, they want ultrasonic quality sensor because they're more familiar with this kind of technology for a long time. And also their technical side, they need to have higher accuracy for the level sensing, for the concentration sensing. So they might choose 1 or 2 types, and they will do a lot of tests. So for the customer side, we will have different options, depends on what customer wants.
Okay, thank you. Yes, any questions for Stephen before we close? Thank you. So first at the back, go ahead, Ignacio.
So Ignacio García Lorenzana from Opel. It's interesting for me to see that although in the passenger car industry, everyone is putting the PAM module into the tank from the bottom. All of them are bottom mounted nowadays. On the heavy duty industry, there is still a majority top mounted. Is there a technical reason for that? And do you see also a trend going into standardized bottom mounted PAM modules? Thank you.
Yep, so good question. A lot of customer or companies also ask the same question, why the passenger car, they more choose the supply module mounting on the bottom of the tank, and heavy duty, they more choose mount the supply module on the bracket independently or on the top of the tank. So first of all, this is also for the space and design side. For the passenger car, because the tank more mount inside of the cover. So if you want to do the service work, you have to consider, like if you want to change the pump, AdBlue pump, if this pump is mounted on the top of the tank, it is very difficult to do the service work. You have to disassemble everything, and then take the tank out and to replace the AdBlue pump. But if you mount the AdBlue pump on the bottom side, it is easy to do the maintenance work for the passenger car. For the heavy-duty side, because heavy-duty, they have enough space to mount the AdBlue pump. Either they can choose top side or the bracket mount on the side way. So for the heavy-duty side, previously more independent mounting, but right now more integration on the top of the tank. Because if you mount the supply module on the bottom of the tank, it is really a challenge for the vibration. Because for the heavy-duty supply module, typically their dosing volume is higher, or heating efficiency is very high for the supply module. So the total weight is also very big for the supply module. If you mount on the bottom of the tank, the leakage problem and the vibration is also a consideration. So right now, for the heavy-duty, middle-duty sides, mostly they choose independent mounting on the top of the tank. But for some of the light-duty vehicles, they also have some integration on the bottom of the tank, because this light-duty vehicle, the pump total weight is also equal to passenger car. So they have different design on this. But I think there is also some reason for the supply module company. In the market, there are not so many supply module companies. In Europe, they have Imitec, Bosch, Energy for the passenger car. So they choose their technical roadmap, how to mount the supply module. But for the heavy duty or for the commercial vehicle sides, there are many system companies in different regions, more than 20. So these companies, they have a lot of different design for the supply module.
Very good explanation. Yeah. Thank you, Stephen. Final question we had in the middle.
Lennart Lindholm, Volvo Global Trucks Technology. You mentioned that bubbles is a challenge for rear quality sensor. When it comes to the three technology, which one is most sensitive to bubbles and which one is less sensitive to bubble, if there is a difference?
Typically for all the principle, the measuring principle for the urea concentration, all different principle will impact by the bubbles. Either you choose optical way or ultrasonic way or the heat transfer way. If the bubble inside of the measuring area, there will be a very big impact to the signal side. So for the principal side, it's easy to impact by the bubble. But the main fact is how you can have better design for the mechanical side. The mechanical side, like for the optical way, we work with TT. We make special cover, the housing, and also rubber parts on the outside of the sensing area. And this will protect the sensing area and reduce a lot of bubble going inside to the sensor measuring area. And for the ultrasonic way, the same principle. We also have special design to protect this area. For the heat transfer way, our partner, they also have done a lot of tests to open a small hole on different position and also different transfer channel to make sure the bubble is difficult to go inside. So principally, yes, bubble will have a lot of impact to every principle. But this depends how you can design your sensor out frame, and also you can use your software to also do some of the filtering for this. And till now, in the laboratory testing and on-road vehicle testing, we saw most of the bubble problem for all these 3 sensors.
Thank you. It sounds like it's an important challenge to account for in your design. We should move on now, so I'm afraid that's the end of the questions for the moment. Stephen, thank you again for your presentation.